Myself, Professor M. Anzado from KKWAC Polytechnic. Here we'll go into the session for Introduction to TRIAC, which is a member of thyristor family. What is TRIAC? TRIAC, it is nothing but a three-terminal AC switch, and the terminal names are MT1, MT2, and gate terminals. This device is basically used for AC systems, and the basic purpose is as a switch. The word TRIAC stands for triode for alternating currents. Shortly, it is the three terminals, four layer and bidirectional semiconductor device and the member of thyristor family. Here, the basic components we are observing and the symbol for the TRIAC is here. Let us see the construction of TRIAC. The construction of TRIAC in which two SCRs are connected in anti-parallel and the gate terminal of both SCR is a common one. The gate terminal is connected to both the N and P regions, due to which the gate signal may be applied, which is irrespective of the polarity of the signals. That means the device may be turned on if the gate signal may be positive or the negative. Here we are observing the constructions as well as the construction which is in the form of layers as well as the constructions in which two SCRs are connected in anti-parallels. Now let us see the different triggering modes for TRIAC. Basically, they are treated as or termed as mode 1, mode 2, mode 3 and mode 4. And all these modes of operations, they are dependent on the polarity of the terminals and the voltage across the gate. So in mode 1, we say that if MT2, the terminal is positive and that time the gate current is also positive. In mode 2, MT2 is positive and the gate current is negative. In mode 3, MT2, the terminal is negative and the voltage applied to that is also negative. And in MT4, the terminal is negative and the gate voltage is positive. In this, we are observing, or we have to remember that TRIAC operates only in mode 1 and mode 3, or we say that it operates in quadrant 1 and quadrant 3. In quadrant 1, at that time, we say that main terminal 2 is positive as well as the gate voltage is also positive. And in quadrant 3, the main terminal MT2 having negative voltage and the gate also having negative voltage. These are the operating modes or the operating quadrants for the TRIAC. Now this is the characteristics for the TRIAC. Basically, it having three regions of operations. That is, we say that initially when the TRIAC is in off state, the voltage across it is very high, that we have to treat as an off state. Then after the breakdown voltage for the TRIAC, when it comes in conduction, at that time it goes in conducting state, or we say that it is the on state of the TRIAC. When the TRIAC goes in on state, at that time the voltage across TRIAC decreases. And just we learn that it operates in first and third quadrants. So the waveforms we are observing here in first and third quadrants. And one more thing is that the waveforms are symmetrical in nature. That is, their breakover voltages are identicals. So here VBO represents forward breakdown voltage in first quadrant and VBO another term that indicates reverse breakdown voltage in third quadrants. When the device comes or goes in on state, at that time a heavy current flows through it which may damage the device, and hence in order to limit the current, or we have to use a current limiting resistor which is connected externally to the device. And also we have to take the precaution that we have to apply the proper gate signal. But the firing angle of the device, it may be controlled. These are some advantages, disadvantages, and the uses of TRIAC. So the advantages, it is going to trigger with the positive and negative polarity of the gate signal, that is a plus point. So there is no wastage of power. Second point, it requires only a common heat sinks. Third one, it also requires a single fuse for the protections, even though we are using two SCRs, but they are in anti-parallel or combined form. The disadvantage is that they are not reliable as compared to SCR. They are having lower dB by directive rating as compared to SCR. And in a market, they are available at lower rating as compared to SCR, that is silicon controlled rectifiers. And also we have to take care about the triggering circuits for the device. The TRIACs are used in various circuits. They are basically used for high power lamp switching or lamp diverter circuits. They are used in control circuits. And the main use is that they are used for the AC power control or AC power control switch. And the other applications which may be domestic purposes, that is for fan speed control or another motor speed controls are there. Here, there is a comparison for SCR and TRIAC. We can observe the different points as SCR is a unidirectional device, whereas the TRIAC is a bidirectional device. The SCR is going to turn on only a positive gate current, whereas the TRIAC can be turned on with positive as well as negative gate currents. In SCR, anti-parallel SCRs are used for bidirectional current flow, where in TRIAC it is equivalent to a pair of anti-parallel connected SCRs. The ratings for current and voltage is high for SCR as compared to that TRIAC having low current and voltage rating. SCR operates only in the first quadrant, whereas TRIAC operates in first and third quadrants. The SCR having better gate current sensitivity as compared to TRIAC. The firing angle circuit for SCR is very simple, but we have to take precautions for the firing control circuit for the TRIAC. SCR having lower turn on and turn off times as compared to TRIAC, whereas the turn on and turn off time of the TRIAC is very high. So these are the points of comparison for SCR and TRIAC. Thank you.